Alright, you ready for the easy chapter? We had the easy chapter in chapter 5, and this chapter is just as easy. In fact, some say it's easier. Don't have to do much math, but it starts off with a formula that you don't even use, so we don't have to worry about that. Probably we don't even use that one. The book actually says we won't even use it, so I don't understand why it shows it. The main thing that you need to concentrate on in this chapter is the bell curve. And that's what we worked our way up to since the first unit. That's why it's so important for you to be drawing the bell curve whenever possible with your standard deviation and your mean. First of all, there's two kinds of distribution. First type is uniform distribution. And you might want to write that down. Uniform distribution is when there's no variation. No variation. So what does it look like? Well, uniform distribution is going to look like this. That's what uniform distribution is going to look like. Uniform distribution means there's no variation. Sweet and simple. The area under the curve is still 1. The reason I write 4 digits is in this chapter, 4 digits means area slash probability slash percentage. All 3 of those are the same thing. 2 digits means z-score. Example, 1.0000. I carry that 4 digits. That means that's an area. 2.32, that's a z-score because it's 2 decimal places. Okay? So get used to seeing 4 decimal places for area, 2 decimal places for z-score. Now, if the area under the curve, whether it's normal or uniform, is 1.00, and we have the distance right here, then we can figure the what? The height. Because base times height is equal to what? Area of a quadrilateral. So let's say this distance is equal to 10. 10 minutes, 10 meters, 10 whatever. And that would be 10 times h is equal to 1. Divide by 10. Divide by 10. H is equal to 1/10. And that's what we're going to be doing whenever you're given a problem with uniform distribution. Example. They usually give you an example with minutes of a class or something like that. Let's see if I can find one. I guess you're not going to give us one, so I'll have to find one in the homework. It's usually the first couple of problems that are uniform distribution. Okay, here's one. It should say somewhere, okay. The waiting times between a subway departure schedule and the arrival of a passenger are uniformly distributed between 0 and 6 minutes. Find the probability that a randomly selected passenger has a waiting time greater than 2.25 minutes. So the first thing you're going to do is draw your handy dandy uniform distribution, because it says uniformly. And what's the area in that box? 1.000. And what is the base? Here's the base right here, 0 to 6. 0 to 6 minutes. So now we have our formula. Base times height is equal to 1. 6 times h, is equal to 1. Divide by 6. H is equal to 1/6. Now, the base is equal to 6. The height is equal to 1/6. So now I'm going to erase the 1.00. So we've got to draw on the, and 1 minute, 2 minutes, 3 minutes, 4 minutes, 5 minutes, 6 minutes. And they want to know, what is the probability that a randomly selected passenger has a waiting time greater than 2.25 minutes? So you take your handy dandy blue marker and you draw a line at 2.25 minutes. And you want to find that area. So all you do is take your base, which is this right here, which is 6 minus 2.25, and that gives you what? So take 3.75 and multiply by 1/6. So go ahead and take your calculator and do that. 1/6 is 0.166666, or just put in 1/6. And what do you get? Give me 4 decimal places. .75 times 1/6. What did you get? 0.625 even. Everybody get that? So your answer is 0.625, if that calculation is correct. All right, you try this one. Waiting time between subway departure schedules and the arrival of a passenger are uniformly distributed. Can't quit yawning. Between 0 and 9 minutes. Find the probability that a randomly selected passenger has a waiting time less than 0.75 minutes. 0 to 9. So that means that height is equal to 1/9. Find the probability that a randomly selected capacitor has a waiting time less than. Less than means to the left. Left, less. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And 0.75 minutes is 3/4 of a minute. And less than means left. So this one's easy because you don't have to do any figuring. You know that base is what? 0.75. So it'd be 0.75 times 1/9. Somebody tell me what you get. 4 digits, please. 0.833. So you got an 8% chance of waiting less than a minute, or 0.75 minutes. .083. And you feel good about yourself. Now, you're talking about on a test, you're talking about maybe 1 or 2 questions on Chapter 6 test. So there's your 2 questions right there. Not going to spend a lot of time on uniform because what's the only thing in real life that you can say is uniform that does not change whatsoever? Good job. Time. It's the only thing that we cannot change. It's the only thing that doesn't slow down. It's the only thing that doesn't speed up. It has no change. So, with that in mind, now that depressing as that is, why do I not spend a lot of time on uniform distribution? Because hardly ever do you run into anything that's uniformly distributed. Most of the time you're going to run into normal distribution. So we're going to spend more time on normal distribution than we are uniform distribution. So let's turn back to our handy dandy book and go back to uniform distribution. Normal distribution. Now, a long time ago, I told y'all about z-scores, and I told y'all about normal distribution and how to draw it on the normal distribution curve, and there it is. Now, I also told you to remember that the normal distribution is kind of like a gas tank. You read from left to right. That's about half a tank. That's about 1/4 of a tank. Two standard deviations. I told you this part right here was about 0.5, and I told you this right here was about 0.25, and I told you this right here was about 0.75, and that was full, and this is empty. Remember me telling you that? Well, that's how you're going to read it as far as your probability with the normal curve. If we read from left to right, you're talking about 0% here up to 100% here, or 0.0 up to 1. All right? The area is going to be 1. The whole area from this point right here to this point right here. But you got to read it kind of like a gas tank, with this being half full. Because after half full, the z-scores are positive. under half full, the z-scores are negative. So common sense wise, if you pull a 2.23, you know that you're going to have a more than 50% probability. Versus negative 2.23, you know you're going to have less than 0.5 probability. Now the reason that's important is because some of y'all will get the z-table mixed up and you'll read a negative z-score when you're supposed to be reading a positive z-score, and you're going to get like the opposite area, and you need to use that common sense tool to say, well, wait a minute, that's not right. This over here cannot be 23%. This has to be somewhere around 90%. And see, that common sense kicks in. All right? Now, remember how to get the z-score. Z-score is equal to x minus x bar over standard deviation. I'm sorry, I mixed my parameters up, sorry. Yes. Or z for the population, this is for the sample. Z for the population is equal to x minus mu over standard deviation. It's the same formula, just different parameters. Now, in this section, in 6.2, in 6.2, your mean is always going to be equal to 0, and your standard deviation is going to be equal to 1. Now, that's in this section, in 6.2. In 6.3, it changes, and that's when it gets a little bit more complicated, but not much. All right? What they're trying to get you to do now in 6.2 is learn how to read the table and learn how to use your calculator. I'm going to show you both. Alright? Now, first of all, in your book, those of you that have a book, go ahead and turn to A2 in your table, and I will see if I can find it in here. Somewhere in here there's a table. There it is. A, and then go to A2. It's the one that says negative z-scores and positive z-scores. If you do not have a book or a table, you can easily Google it by typing in Triola and then whatever edition this is, and then put z-table, and then it'll pull it up, and then you print it out. Of course, that means you have to print out 2 pages, which is a lot of work, but some of y'all might be able to do it. This is what it looks like. Now, how do you use it? Well, like I said, these are 4 digits. If I see those 4 place values, so what are these in here? What are those? And that's not rhetorical. I'm asking the class to interact with me. What are these? No. 4 digits is what? Area, percentage, or what? Probability. That means the blue shaded area. That's this area right here. These are what? 2 digits. So what are these? Z-scores. Now, in 6.2, you're going to be given 2 types of problems. One, you're going to be given a z-score, and you find probability. Or you're going to be given a probability and you find what? Z-score. Now that's what you're going to be doing in this section for homework, and that's what's going to be making up your test from 6.2, these two type questions. So, there's 2 or 3 things that you have to know about this table before we get started. One is, everybody take your highlighters out, and I'm going to highlight this in red because it's important. Everybody highlight that right there. Because in your table, on the z-score, negative z-score and positive z-score table, all the areas that you're looking up are from the what side? Left side. Well, that means less than. As I told you, left means less than, right? Left means less than. If less than means less than, do we have to worry about anything else? Yeah. You have to worry about greater than. What does greater than mean as far as the right or left hand side? What is greater than? That's the right hand side. So the right hand side is equal to 1 minus the left hand side. And you need to write that down because sometimes the problem may ask for greater than the z-score of 1.5 or greater than a probability of 95%. If it says greater than, then you've got to remember this because your table only gives you the left-hand side. Okay? The table only gives you less than. And what is the complement of less than? Greater than. And the complement of the left-hand side is, or the right-hand side is 1 minus the left-hand side, or vice versa. So everything that you're going to be given on the negative z-score and the positive z-score is the area to the left of your z-score. These areas all right here are to the left of whatever z-score you're looking up. So if I look up negative 3.02, negative 3.02, and negative 3, that's 1, that's 2, that's 3. Negative 3.02 is right in there. I'm looking up this z-score, this probability right here. And that probability right there, 3.02, is 0.0013. That's that area right there. Now if I want the right hand side, then I have to take 0.0013 away from 1, and that would give me 0.9987. 0.9987 is over here. Now the reason you have to be familiar with the table is because sometimes your calculator will die. Sometimes you forget your calculator. And the table is not that difficult to use. You just got to be able to read. Okay? And you got to be able to know when you're looking for the right hand side and when you're looking for the left hand side. And you really know that by knowing how to read and knowing that greater than is right hand side and less than is left hand side. So let's look at one. I'm just going to pull one out of here because they're a whole lot easier to understand. Alright, I'll blow it up for you. You don't have to read the directions. All you got to do is draw the picture. Now this is the section where I tell students to take a piece of notebook paper or a piece of printer paper, divide it up into 8 sections, and draw a bunch of bell curves and put 0, 1, 2 to the right, -1, -2 to the left, and run about 15 copies, because you're going to be drawing this thing over and over and over and over. So just a little hint, you might want to do that. Or you could go to Google. This is for those people that don't want to work a lot. Those people that, don't want to print or, copy. Pull up normal distribution curve with z-scores. And hit images. There it is. And you can take that right there and you can save that as whatever. I think I saved it as downloaded. Pull up your Word document and insert and I'm not used to, where's picture? I'm looking for picture. There we go. Insert picture, download, and you can fit it however you want to. Move it down a little bit and then put one of these on each, put 6 or whatever. Copy, paste, and you can move it over a little bit if you can work dadgum. Well, I'm trying, people. You're supposed to be able to move it. It's not going to move it. Okay. Then maybe copy the whole thing. Control C. Control V. Control V. Control V. And now you got your dang old, maybe one more. There you go. Now this takes a lot of work, so some of y'all might not be able to do it. And then you just print that off 5 or 6 times and run your copies or whatever, and therefore you don't have to draw this out every single time. That took, what, a minute maybe? So that's something you might want to try to do. Instead of drawing, you're going to get sick of drawing those bell curves, let me tell you. Alright, let's go back to the problem. Alright, there's our problem. Now, what are we given? We're given an area. Okay, we're given a probability. We're given a percentage, 85%, 0.85 probability, or an area of 0.8508. You know it's a probability because it has how many digits? 4 digits. So that means we're given a probability. We need to find the z-score. Now somebody tell me, hold on a second. Take our handy dandy straight line maker. Wrong one. What kind of z-score are we looking for? A positive z-score. And the reason we know it's positive is to the right of the 50%. Right of 0. So we go to our handy dandy positive z-score finder. As soon as I can get out of this. There we go. And go to it, and even if you don't have a table, there it is. And I'm going to take my handy dandy line maker and I'm going to find, what was the 0.85 what? 0.8508. So I'm going to take my straight line maker and I'm going to find 0.8508. Here's 0.85. Now what I tell students to do is I tell students to change it into dollars and cents. Because y'all know y'all can do dollars and cents in microseconds. 8508, is that what it was? All right, I'm looking for $85.08. $85, there's $85.54. There it is, right there. Now, the reason I tell people to change it to dollars and cents is sometimes it's not going to fall on these numbers exactly. Sometimes it's going to fall between them. And you've got to decide which one's closer. And if I change that to $85.08, and it's between these two guys, then you're going to be able to tell a whole lot quicker which one's closer. And we'll get to that when we get to one of those problems. So 8508, take my handy dandy line maker. 8508 goes here and there. So this is 1.1, and what's $1.10 plus 3 cents? I'm asking y'all. $1.10 plus 3 cents. So your answer is 1.13. So your z-score for that problem is 1.13. Okay, I'm sorry. I grabbed the wrong one. You're right. Hold on. Let me fix that. I'm just making sure y'all wait. Alright, there we go. 1.10 and 4. So that's why y'all were hesitating. Okay. So what's $1 plus 4 cents? 1.04. I grabbed 0.8708. I'm sorry. 8508. And that's 1.04. So your answer for this problem is 1.04. If I could ever get on there. There we go. And you type in 1.04 and you feel good about yourself. Alright, here's another one. 2358. Positive or negative z-score? Negative. This one don't give you your table, so you have to go find it. So let's go find negative z-score of 0.2358. Yeah, 0.2358. So we look down here, and I'm looking for 0.2358, and I see 0.2358 right here, and I go with my handy dandy line maker. 0.2358. I had it right here. There we go. Negative 0.7. And I don't have to go because this is 0, 1, 2. So what is 70 cent plus 2 cent? 72 cents. So your answer is negative 0.72. And that should be your answer for the z-score. And like I said, when they're like that and they're, well, sorry. There we go. 0.72. Negative 0.72. When they're right on the money, there's no problem. But sometimes they're going to be not right on the money. They're going to be between them, still trying to find one that's between them. So y'all just bear with me. 0.7673. Now what's wrong with this one? It's shaded to the right. So this is greater than. So you've got to find the z-score to the left. I meant the area to the left that corresponds with the right score of 0.7673. So somebody take your handy dandy calculator and take 1 minus 0.7673 and tell me what you get. 0.2327. What? Okay, 0.2327. And that's what you're looking for on the z-table. 0.2327. So you go to your handy dandy z-table. And you find 0.2327. 0.2327. right here. And that is 0.70123. So negative 0.73 should be your answer. Negative 0.73. Still not the one I'm looking for. Let's see if I can skip to another one. Bless you. No, we don't want to skip there yet. Okay, let's see. Less than 1.69. Well, we'll find it eventually. Alright, go ahead and find this one. This one's going to be 0.8729. Somebody tell me that's right. 0.8729. So you need to find 0.8729. And it's going to be a positive z-score, so you need to look on the positive table. 0.8729. There it is. 0.8729. I had it a while ago. There it is. 1.1 plus 4 cents. That would be $1.14, right? So you go back to and put 1.14. And those are given areas, find the z-score. Okay, read this one. It says blah, 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 blah. Find the probability that a given z-score is less than 1.62, negative 1.62. Now, they're telling you to draw a picture because that's very important for you to actually see the problem and see what you're looking for. That's why you need to do one of these, okay, because it's going to get very old, you know, writing these things over and over and over. So, which one is less than negative 1.62? A. Now you want to find the probability. So find the probability. Well, you go to your handy dandy negative table and you pull up 1.62. Negative 1.62. So you take your handy dandy line maker. 1.6012. So there's negative 1.62 right there. And what is that? 0.0526. 0.0526. Alright, let you do this one. Find the probability that a given z-score is less than 1.92. So draw a picture of it, then find the z-score. I meant the probability, sorry. So which one is less than 1.92? A. Go to your handy dandy right positive z-scores and look up 1.92. So that'd be 1.9. And then I count over because I don't want to have to go up here and read this, so I just count over. So 1.9, 0, 1, 2. So 97%, 0.9726. .9726. All right, try this one. Find the probability that a randomly selected thermometer reads greater than negative 0.48. Reads greater than negative 0.48. Of course, A is your picture. So we need to look up negative 0.48, and that'll give us the left-hand side, but then we have to subtract that from what? 1, because we want to know the right-hand side. So negative 0.48, take our handy-dandy table, negative 0.48, so that'd be negative 0.4. If I could work this line. There we go. And I count over. So negative 0.4, 0, 1, 2, 3, 4, 5, 6, 7, 8. I got 0.3156. Now, that's the left-hand side. The right-hand side would be 0.6844. Somebody check me. .6844. So .6844. All right, look at this one. Read it and write it down and put a star beside it, because this is where things change a little bit. How do they change? Well, this one is not asking for greater than or less than. It's asking for what? Between. Say J. Peters burned down. Which one? They know why? right. Now a lot of people kind of a little bit don't know or a little apprehensive about this problem. So I always tell them we're in Anderson, and right up the road is the big metropolis wannabe of Greenville, and then Spartanburg. And we know that it's about 30 or so miles, I'll just say 30, from Anderson to Greenville. And then we know that from Anderson to Spartanburg is about, let's say something simple, let's say 50 miles. So if I was to ask you what is the distance between Greenville and Spartanburg, what would you tell me? You take the larger and subtract the what? The smaller and get 20 miles. So how do you relate that to this problem? Well, the same thing. If you're given a larger area, you subtract the smaller area, and that will give you what? 1/3 Okay? So when you're given between, just remember to subtract the larger area, the smaller area from the larger area. So in this case, which one is between? Well, it's not these two because these don't have anything between. This one does. So there's your picture. Again, it's good to see it because you're going to take this area, that's the larger area, and you're going to subtract the smaller area. And what's left is this area right there. So it's just like subtracting the distance from Greenville to Anderson, from Anderson to Spartanburg to get the remaining distance right there. So you got to look up 0.25 and 1.5. They're both positive, so we can look on the handy dandy positive. 0.25 is 0.5987, right? Make sure I look that right. Yeah, 0.5987. So let's write that down. And that's the smaller of the two. What's the other one is 1.5. 1.5 is going to be 1.50 is 0.9332. Somebody subtract those. Too much barring. I'm not going to do it. I'm too lazy today. What is it? 0.9332 minus 0.5987. What do you get? 0.3345 and 0.3345. .3345 is that area right there. Alright, try this one. Assume that a randomly selected blah 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 blah. Find the probability that a given score is less than 3.81. Well, I think everybody understands that this is the... And the only thing they're trying to show you here is that if you get a score above 3.5, your answer is going to be 0.00 or 0.99999 is what they're trying to tell you. So you automatically know that it's above 2.5 or 3.5. 3.5. Anything above 3.5 is 0.99999. Alright, look at this one. I'm going to let y'all do this one. I'll blow it up for you. Because it's worded differently. Try to discourage you, confuse you. First thing, draw a picture. This one says, draw a graph and find P sub 2, the second percentile. This is the bone density scoring or score separating the bottom 2% from the top 98%. So they want you to find 0.0200. So I would say it's probably C. The bottom 2% from the top 98%. So you got to find 0.0200. So you go to your handy dandy z-score, and it's going to be a left negative z-score. 0.0200. So that's $2. 0200. There we go. Now we find in one that's in the middle. So you want to find $2. So let's look down here. Here we go. Right here. $2 is right here. Which was closer? $2.02 or $1.97? That's not rhetorical. I'm asking for that. Instantaneously. So $2.02 is 2.01. 0, 1, 2, 3, 4, 5. So 2.0 what? 5. Negative 2.05 is your answer. And you feel good about yourself. What does this one say? 0.0900. And you find that one. And they're asking for the percent of the area. So they're finding between 1.7. That's finding between negative 1.7 and 1.7. I'm going to let y'all do that one. I want to move on to the next chapter, section. Now, as I told you, 6.3 is probably where most of your questions on the test is going to come from. Okay? 6.3, I would say probably 70% of your test questions are come from 6.3. And that's because you're going to use the z-score. There's your formula, which I already gave it to you. Now, what's the difference in these questions? Well, I'm going to show you. I'm just going to show you the problems because it's a whole lot easier to do it here than look in the book. Alright, here is the problem right here. It says, find the area of the shaded region. The graph to the right, depicts IQ score of adults, and those scores are normally distributed with a mean of 100 and a standard deviation of 15. That's the difference. In 6.3, the mean and standard deviation is not going to be 0 and 1. The mean and standard deviation is going to be something totally different. So, the first thing you do is you draw a picture. Not in mauve. Don't show up good. And always do 2 standard deviations, and of course if you have to draw these every single time, you're going to get sick of doing it. So that's 100, 115, 130, 85, and what? 70? And they want to know what is between. Okay, they just show you the picture. Okay. Find the area of the shaded region. Okay, between 80 and 110. They want to know this region. Well, first of all, you can't do anything with that unless you change the z-scores to look it up on the table. So, for the 80 minus 100 over 15. And somebody do that for me. Over here, 110 minus 100 over 15. So what's the 80 z-score term? What is it? 80 minus 100 over 15. I know it's negative. Just tell me what the answer is. 1.33. Or 1.33 is good enough. So there's your z-score there. And somebody give me the z-score for 110. What do you get? 0.667, whatever. Now use your common sense. This is 1. That's 1 and that's 2. So yes, that'd be somewhere around 0.67. And then this one over here is negative 1.33, and that's negative 1 right here. So yes, it's over negative 1. So yeah, that comes out to be about right. So now you have to find the z-score table for 0.67, find that area, and subtract this area. So go to your 0.67. 0.67, 1, 0, 1, 2, 3, 4, 5, 6, 7. I get 0.7486. 0.7486. So the area is 0.7486. That's for the area for 0.67. Area for 0.67 is equal to 0.7486. The area for negative 1.33 negative 1.33 negative 1.30, 1, 2, 3. I got 0.0918. Somebody check me. 0.0918. And that's the area for negative 1.33. Subtract the 2. And what do you get? .6568, and that is your area right there, 0.6568. Now, right quick, get your calculators out. Everybody get your calculators out. Now, in your calculators, you can do the same thing. It says it somewhere in here. I got to find it. I don't even know what section I'm on right now. Let me go to 6.2. It should be in 6.2. There it is. Second bars, normal CDF. So let's go to second bars, normal CDF. Second bars, normal CDF. And give me that last problem. What was the z-score from where to where? 80? Negative 1.33. So negative 1.33, comma, to what? 0.67, and close parentheses and enter. 0.6568. And I think that's what we got, didn't we? Something like that. Now, what do you need to do to infinity? Well, let's say we're going from 0.67 to infinity. Excuse me, the right-hand side. So we type in second function, entry, and we type in negative or 0.67. Delete, delete. And I always use 4 nines. 9999. You can use 3 nines, 4 nines, 5 nines, 10,000 if you want to, and that will give you enough for infinity. Bless you. 0.2514. Now that's the right hand side. What if you want the left hand side? Well, negative infinity is 0.67. Type in second entry. So if you want the left-hand side of 0.67, you type in negative 9999, comma. Was it negative 0.67 or 0.67? 0.67, close parentheses, and that'll give you the left-hand side. And that's how you use the calculator instead of the table. Use whatever you want to, all right? But at least know how to use both.